Welcome to Homework Lib.
We're going to do some nucleophilic aromatic substitution, which is a bit different. And we're going to, be involving parafluoronitrobenzene. And we'll be comparing it to parachloronitrobenzene. Okay, so if we subject the two to some hydroxide, the first step will be, this attack at that site. Okay, and the last step will be green here, which will be loss of the leaving group. So NAS typically is a two-step reaction. So if we're told that the fluoro group actually, that this one right here is most reactive to the hydroxide. Okay, what that's telling us is that there's something specific about the fluorine component of this reaction that is able to, speed up the rate, and that it's actually rate dependent. So the halogen, what that's basically telling us is that the halogen, something about the halogen is very rate dependent. Okay. Okay, yeah, so the halogen is very involved in the rate limiting step, such that changing the halogen will affect the rate and the overall reactivity of this NAS. Okay, so as you can see here, step number 1 is hydroxide attack, and step number 2 is loss of the leaving group. So what that's telling us then is, the part where the halogen is involved really is in its loss, okay, which is actually the second step. So then we can see that this is actually the rate limiting step then. Okay, and that's because of this point here. If changing the halogen will affect the rate, then the halogen is involved in the rate limiting step. So the only step that we can see here where the halogen is really doing something is in step 2, where we get the loss of it. Okay, also just for extra information, what's in between step 1 and step 2 is the intermediate, which is the carbanion intermediate. Okay, so if you look at what's really happening over there, we have the carbon fluorine and the carbon chlorine bond that is about to break. Okay, so here we can see we actually have good orbital overlap. So if you just look at your periodic table, you'll see that the chlorine and the fluorine are actually within the same row, within the same family as each other. So their orbital size is actually very similar. While here, the chlorine has a 3p that has some unfavorable overlap with the chlorine. Okay, so it's just going to be harder to really be involved there. So this may or may not be true, that this is the second step is the rate limiting step. But according to the information given, we would have to assume that the second step is the rate limiting step since it involves the hydrogen or the halogen.